In this example, we're going to find an eigendecomposition for matrix A. First thing we need to do is find the eigenvectors. So, in order to find the eigenvalues, we look at the determinant of A minus lambda I. And so we're looking for the determinant of negative lambda, 1, 3, and 2 minus lambda. That determinant has to be 0. So we have negative lambda times 2 minus lambda minus 3 is equal to 0. And here we get lambda squared minus 2 lambda minus 3. And so two numbers that multiply to negative 3 but add to 2, negative 2, are lambda minus 3 and lambda plus 1. So our eigenvalues here are lambda equals 3 and negative 1. Once we have that, we can start finding the eigenvectors. So when lambda equals 3, we have our matrix A minus lambda I is going to be negative 3, 1, 3, 2 minus 3 is negative 1. Okay. And so when we multiply this matrix by our vector xy, we get 0. And so here we've got 3x equals y, which gives us the vector y equals 3, x equals 1. So that's our first eigenvector. If we want to normalize it, we can do that. Lambda equals negative 1. We get negative 1 is positive 1. 1, 3, 2 minus 1 is 3. And so here we have x is equal to negative y. And so our eigenvector here is if y is equal to 1, x is equal to negative 1. Great. Now that we've got our eigenvalues and our eigenvectors, we can create P and D. P is going to be the matrix of eigenvectors. So 1, 3, and negative 1, 1. D is going to be the matrix with the eigenvalues along the main diagonal. So 3 and negative 1. Now, we need to find P inverse. So one thing to remember here is if we had normalized those guys, finding the inverse might be a little bit easier. But in the event P inverse here, we have 1 minus 3. So 1 over 4 times 1, 1 minus 3, 1. Okay, and so A is equal to PD P inverse. And we can double check that. So that's the eigendecomposition for A. Now, if we want to use this eigendecomposition to find A to the 4, so this is PD P inverse to the 4, which is PD P inverse times PD P inverse times PD P inverse times PD P inverse. We notice that the P inverse P's are going to cancel everywhere. So there, there, and there. What we're left with after we cancel them is P D to the power of 4 P inverse. Now that's still a lot of matrix multiplication, but since D is a diagonal matrix, the D to the power of 4 is simply D with the main diagonal elements raised to the 4th power. So this is going to be our matrix P, 1, 3, negative 1, 1. D to the power of 4 is 81, 0, 0, 1. And P inverse is going to be 1, 1, minus 3, 1. And we'll put the 1/4 at the end. And so, well, you have to multiply 3 matrices here. Computing A to the 4 requires multiplying 4 matrices. And in fact, if you wanted to compute a higher power of A to the 10, it still only requires multiplying 3 matrices rather than sort of some multiple of A. So there you have it.